Alright, now we'll see the implementation of the first question. This is set 1, question 1. And we realized that to implement this in CX Programmer, that we have to, for this is an example of when I use a CP1E, okay? So in this case, if we press the start button, okay, what should happen is that it will move 0 to D0, and it will stand by all the comparison, and you can see that the solenoid door straight away unlocked because now it's 0, right? So that we are comparing to 10. So in this example, I just put 2 just to show you how the operation happens, okay? But the answer should be 10, okay? Hash here should be 10, okay? So we'll see that when we set the entry sensor detect the entrance of one person, then we can see that the accumulator D0 is increased, okay? So for example, if another one goes in, set off, if another one goes in, okay, you can see that it goes to 2, okay? So when it goes to 2, because in this example I compare it to 2, and you can see that the solenoid door is deactivated, so it's off. So it's basically straight away locked, and you can see that the time full, the pilot light full, please wait, is illuminated. And we can see that if somebody actually exit, okay, and the solenoid door is on again, okay. So basically it's about the same thing with other program. I'll just take a look at the second one. The second set, okay. So with the second set, the difference is that you have 2 different pilot light, okay. It's basically the same thing because you have entrance sensor at the front, and then you have the push button, okay. So here the difference is that you have entry sensor here and then the exit push button, but both of them are still connected to a differentiate bit, okay. So what happens is that supposedly, I'll just compare to 2 for this time being. It's supposed to be compared to 12, okay. Alright, so to show you the simulation, so basically if we take a look at when we start the system, then obviously the solenoid door is unlocked, okay. Then you can see there is P_LT, which is the less than flag. So because comparison is done to 12, okay, so in this case I'm just putting it 2 for the viewing, for us to actually see what happens, okay. So because it's 0 now, it's less than 2, then we have solenoid door unlocked. So if if somebody goes in, so that if there is a 2 person, we can just go straight away to a maximum, okay. So if there is a 2 person goes in, straight away the solenoid door is locked, and then full and please wait pilot light will be illuminated, okay. Alright, so if we take a look at the third set, okay, so the third set is I believe it's the queue at the drive-through, okay. So the difference is that instead of a solenoid, okay, it is a motor which should rotate counterclockwise to open the gate, okay. So it depends on how you define this, okay, it doesn't matter, but the operation is still the same. Comparison must be compared to 8, okay, because there are 8. So it's the same operation, okay, throughout. So if we do the simulation here, we can see that it's basically the same thing, okay. So you initialize first, okay, and then if there is an entry sensor 1, okay, then the motor is on. Alright, and then if there is an entry sensor another one, then obviously the motor is off, and then there is a full sign. Okay, alright, so because in the question that I have said that the mechanism of closing is in place, so you don't really have to worry about programming on the mechanism itself. But if you do, well, that's good, then I'll just mark that lah. Okay, but this is the main idea of the solution. Okay, alright, and then so the last one is about the roadblocks. Okay, so those who get set 4, you have roadblocks. So the difference here is that the motor itself is because you have one entrance barrier, you have 4 exit barrier. So there are one entry sensor obviously, and there are 4 exit sensors. Okay, so we have to make sure that the entry cannot be or the entrance gate of the barrier gate will not be open if all of the inspection area are full. So that means the accumulator must be compared to 4. So the difference is that if we put a simulation here, we can see that if, for example, entry is 1, okay, then 2, and then a 3, and then 4. We can see that the please wait is on, and that the motor itself will be disabled, and we will lock the barrier. So basically, if any of the car has finished first, okay, say at the second part or at the second inspection area, so when this sets on, straight away it will open the gate. Okay, so so basically, for example, if somebody goes out, okay, and somebody goes in again, okay, just one car, it will disable the motor again and say please wait. Okay, so if all of the if 2 of that, for example, at the same time, we will still have the motor with the barrier gate open. Okay, so we can see that with this OR condition, that means any of the gate will decrement the accumulator. Okay, so alright, so I just want to explain a little bit on the top. Basically, this is just by choice that I want to differentiate, use something like this to differentiate bit 10.01. I can use the same thing like this here instead of using this line. It doesn't really matter. So at this point, that if we have some sort of connection to the internal relay, that means like if when there is a start button, I immediately differentiate the bit. So that means that means with starting, I initialize the memory or the accumulator D0 to 0. Okay, alright. Okay, so I think this explains part of question 1. We'll now go to question 2.